Okay, example number 3. In this case, again, to graph the function, we're going to start by factorizing every part of my function. Notice that my function in the numerator is a constant. And remember, a constant is a polynomial of degree 0. That is important. So by factorizing my denominator, I have that this expression is minus 3x plus 1. So once I have factorized my denominator, I can start finding the domain and asymptotes. So the domain for this rational function is all numbers except the ones that make the denominator 0. So these are the factors in the denominator, and if I solve for x in each one of them, I will have the following terms. So the domain is all real numbers except those invalid values. And remember, the vertical asymptotes are exactly the equations defined by those invalid values. Remember, asymptotes are equations, so write them as equations. I'm going to start graphing them. The first one is here. And the other one is here. Now, let's find the x-intercepts. So remember, for the x-intercepts, we're gonna graph the numerator and find its zeros. So the numerator is 7. If I equate it to 0 and find its zeros, we will notice that we have an expression like this. 7 equals 0. Obviously, 7 is not the same as 0, so that means that we don't have any x-intercepts. So we don't have it. Another way to look at it is to say that these functions, you know how they look like. These functions look something like this, because they are constants. So the only way to have a x-intercept would be if the numerator was the constant function 0. And if the numerator is a constant function 0, this would mean we would have 0 over something, so it would be the constant function 0. So the conclusion is, when your numerator is a constant function, you don't have any x-intercepts. Now, going into the y-intercept, remember the y-intercept is found by evaluating the function in 0. So, if I evaluate the function in 0, this would be 7 over minus 3 times 1, meaning this would be minus 7/3. So the y-intercept is in a little bit after minus 2. Okay, the next thing we're gonna find is the horizontal asymptote. Remember, to check the horizontal asymptote, we have to check the degree of the numerator and the denominator. The numerator is a constant, meaning the degree of this polynomial is 0. And the degree for the polynomial in the numerator is 2, because that's the highest exponent. So, because the degree of the numerator is smaller than the degree of the denominator, our horizontal asymptote is just the equation y equals 0. That is a line with the height of 0. That's another place where you can see that everything matches. The fact that our horizontal asymptote is in 0 and that we have no x-intercept makes sense, because we know we cannot cross the horizontal asymptote. Thus, we cannot have x-intercepts in the x-axis. So that's everything we have so far. So let's start graphing. Again, we will start evaluating or graphing, in the place where we have information. In this case, we only have information in the middle part. So let's start there. Notice that I already have a value in or a coordinate in a value next to the horizontal asymptote on the left. The vertical asymptote, on the left side is in x equals -1. So in x equals 0, I know that my function is -7/3, meaning that my function, because the value of the function is negative, the function has no other way but to go to minus or negative infinity. Now, do I have any x-intercept around here? No. That means that my function can never do something like this. So my function has no other way but to go down. To understand better the behavior around here or the shape of this place, of this part, I'm going to evaluate in a number close to the other vertical asymptote. The other vertical asymptote is in x equals 3. So I'm going to evaluate in 2. Why in 2? Because 2 is a number close to this vertical asymptote in this part of the plane. So f evaluated in 2 is 7 over -1 times 3. So this is -7/3. So in 2, my function is again -7/3, meaning that the behavior of this function is going to look like this. Now, to graph in another place in this function, we can choose either side because none of them have any special point. So let's start here. Choose a point to evaluate in this place that is close to the vertical asymptote. The vertical asymptote is in 3, so a close number to it is 4. So I'm going to evaluate my function in 4. This function evaluated in 4 is 1 times 5, so this is 7/5, meaning that the coordinate point 4, 7/5 is going to be located around here. So for a number on this side of the plane and close to the vertical asymptote, my y value is +7/2, meaning that I'm going to go into positive infinity. Also, because I have no other way but to get close to the horizontal asymptote, my function is going to get closer to it without ever crossing it. I cannot cross it because why? It is an horizontal asymptote, and 2, I do not have any x-intercept. Now, to graph the last piece of this function, I have to evaluate in a number in this area that is close to the vertical asymptote, but on this side of the plane. That value is -2. So if I evaluate the function in -2, I get that this is 7 over -5 times -1, and this is 7/5. So in -2, my function is 7/5. So for -2, the function is 7/5. That is around here. So because this is a number close to my vertical asymptote and it is positive, my function is going to go into positive infinity. And again, I have no other choice but to get close to the horizontal asymptote without ever touching it. And that's it.